Guys, this is Joe East here. We're going to talk about battery systems. There's going to be a couple of small clips on some small subjects of battery systems. So today we're going to talk about capacity. What does capacity mean for the average person who might be slightly technical or a little bit technical? Capacity. So capacity is the amount of amount of electrons or energy a battery can contain, okay? So it could be full or empty. It just refers to the amount of stored electrons, as it were, inside. You could think of it as the gas tank capacity, all right? So the weird thing about batteries is that as a battery ages, the capacity shrinks. So you can think of capacity as a battery ages as a shrinking gas tank. So the gas tank starts off this big, right? And then suddenly as it ages, it's going to shrink, get smaller and smaller. So that's one phenomenon a battery system has as opposed to a gasoline engine that you must consider when you say, well, okay, how much energy or capacity I have in this battery storage system or this cell. So let's get to a little bit of the mathematics here and some of the numbers. All right, so our broad subject, battery systems, specifically this clip is on capacity. Let's say you have a lead acid cell, for example. I'm mostly a lithium ion system expert. Let's just use lead acid because the numbers are easy and you can catch on to the number part of it quicker if we do lead acid 2 volts. So let's say we have a 100 amp hour battery. All right, what does that mean? What does that mean? I mean, quickly, it's really easy. All 100 amp hours means that somebody measured this design and said, okay, this thing can drain at 100 amps for 1 hour, then it'll be empty from the state of full. So if it's a fully charged battery, he'll blast out 100 amps for 1 hour, then he'll be empty. That's all that means, 100 amp hours. Now you can plug in how much time it would take to blast out 10 amps or blast out 1,000 amps based on this amp hours, just how fast do you want it to come out, or how long it would take for a particular amount of amperage to come out, or how fast do you want to discharge the battery. So there's two questions. You can answer them with either way using this amp hour equation. All right. So there's another way of measuring battery capacity. So this is the amp hours. Normally, if you're going to be doing system design, you're going to need to know the energy in terms of watt hours. And watt hours is an expansion upon joules, and joules are watt seconds, okay? So watt hours, watt seconds. Joule is a watt second. Fundamental unit of energy, joules. So how do we convert a 100 amp hour cell system at 2 volts to watt hours? Very simple, straightforward calculation. However, let's walk through a little bit of the mathematics. That way, for reference, you can say, well, where did that number come from? And you can rewind this and check it out. Okay, so the fundamental equation for power in electricity is power equals to volts times current, right? P equals VI. Straightforward equation. So if we start out and ask ourselves what we have, given this 100 amp hour capacity at 2 volts, we have amp hours and we have volts. So we have amps, hours, and volts, okay? Amps, hours, and volts. That's what we have, all right? What we need is watt hours, okay? And we're going to use the P equals VI equation to get watt hours, okay? So remember, V multiplied times amps, or volts multiplied times current, all right, equals power. Power is watts, right? Power is in watts, okay? So watt hours. So I need watts. How do I get watts? I grab voltage and current. So there's my voltage. There's my current. There's my equation. So you basically multiply your amp hours times your volts, and that gives you your watt hours. So this is a 200 watt-hour cell. Remember, this is only for lead acid, which is nominal 2 volts. For lithium-ion batteries, you have to know the nominal voltage. And often, some of those lithium batteries, the nominal voltages are not the same, depending on the chemistry recipe. All right, so 100 amp-hour cells at 2 volts comes out to 200 watt-hours. Okay, so that's how you do straightforward energy calculation, given what's commonly called capacity amp-hours. You're also going to run into a phenomenon in batteries rated versus actual or nominal versus tested. And it's basically manufacturing issues, right? I manufacture something, and how far does it deviate from specification, right? It can be ball bearings, tires, cars, or whatever. You're going to have some deviance from specification, some tolerance, right? So you get a 200 watt-hour or 100 amp-hour cell. That's its rated capacity. Now, actual is going to be, of course, there's going to be some tolerance. It's going to be different, right? And also, as it ages, it's going to be pretty far away from manufacturer spec, right? So it could be off as much as 20%, which is, you'd say, 80% of its original, right? But that's rated, and actual is tested. So whenever you are talking about battery capacity, you need to make sure, absolutely sure, you understand what you're talking about, the difference between the manufacturer's nominal or rated capacity versus actual or tested. You have to know those differences, because in batteries, the swing, or should I say the tolerance from rated versus actual can be very, very large compared to other common engineering parameters. So, say you're buying a tire, well, you're plus or minus a percentage point, right? Maybe some engineering tolerances is plus or minus 5%, some of them plus or minus 2, plus or minus 1. Batteries can swing plus or minus 20 and sometimes 50%, I've seen. So rated versus actual. Amp hours, watt hours, conversion of amp hours to watt hours, amp hours to energy. And then now we have our basics of capacity. Now you can go out and do your capacity calculations. Take care. Till the next clip.